No, ma'am.
Yeah, yes,
No, ma'am.
no idea. Okay, no problem. So what basically happens is that you have to store the data in your computer. Data can be of different types. Data can be simply, words, numbers. Data nowadays are also images, audio, video, and different forms. Okay, so how you store the data in your computer? So data is not supposed to be stored randomly, because if you store the data randomly, then when you have to take the data, when you need the data, or when you have to search the data, that time the time complexity will increase. Okay, and time complexity, as you know, is very, very important in case of computer. So we store the data in a certain way so that when we have to retrieve the data, it becomes easier for us. So we have various types of data structures. Some of them are physical, some are logical. And what are these? Basically, we will come to them one by one. Okay. So one example of physical data structure is array. Why it is called physical data structure? Because it actually exists. Array actually exists. Array means what? What is array? Someone? What is array?
Where we store a symmetric way of similar data types.
Not symmetric, consecutive memory allocation is there.
Yes, ma'am.
Okay, that means if you are storing character, if the address is 100, next will be 101, 102, and so on. 1 byte. Okay, so this type of memory is generally consecutive, no matter how you are using it. So the actual memory organization is consecutive. Okay, so array is called physical data structure because it actually exists. In memory is actually consecutive. Sometimes we use it in a consecutive way, sometimes we do not use it in a consecutive way. So if we are using it in a consecutive way, that means we are using the memory as it is present. So array is doing that. Array is using the memory in a consecutive way, and hence it is a physical data structure. Okay. So now array is not in the syllabus of data structure. It was in the syllabus of C programming. And because we have studied array there, so the next data structure we are going to start with is linked list. Linked list, we have already seen a little bit of it in the C programming when we were learning C programming. I don't know if you remember it, but even if you don't remember, it's okay, because the first data structure that we are going to start with is linked list. Now linked list are of various types. Okay, so first is the singly linked list. We have circular linked list, we have doubly linked list, we have priority list, okay, and so on. So first we are going to start with the singly linked list. Okay, so before I start teaching you the theory part, one thing I would like to tell you is that data structure and algorithm is a very, very important subject. Okay, in the sense that in any interview, in any exam, which is technical, okay, if you are going to remain in the technical field, be it a job interview, be it an examination for taking a higher degree like MTech, everywhere you are going to get this subject. It is that important. Okay, and a little bit of algorithm we will learn here, but mainly algorithm is a different subject, design and analysis of algorithm, that you will learn in the next semester. Okay, but these two subjects, data structure as well as algorithm, these two are very, very important subjects when it comes to computer science. So please pay attention and be regular with your classes. Don't miss your classes. If you are regular with the class, I can assure you that you don't have to worry before your exam. I will teach you everything. Okay, you don't have to bother and open your books and wonder what to do. But be regular with your class. Okay.
Ma'am,
Yes.
ma'am, before starting our class, I want to tell you something, ma'am. That in the ERP section, there is the section for recorded video. When we are searching for a recorded video, ma'am, at that time that was not there, ma'am.
Actually, what happened is the person who is responsible for uploading your video, okay,
Yes, ma'am.
that person left. That person is not a part of the college anymore. So that responsibility came on other people who are working for the particular department. Till now, you were not a part of CSE department. You were in general science, okay? But now that you are a part of CSE department, so I will tell the technical staff who is in the duty of CSE department to do the needful. Okay, so I think this time you will not face problem.
Okay, ma'am. Okay, ma'am. That was the problem. Please,
Okay, okay.
okay, ma'am. Thank you.
No problem, no problem. It will be solved.
Ma'am, can you please explain the time complexity when you sometime?
Yeah, I will explain everything. You don't have to worry. Just be
Okay, ma'am.
regular with the class, everyone. And that
Yes,
is the only thing I have. That is the only demand I have. You be regular with the class, rest I'll take care of.
yes, ma'am. Okay, ma'am.
So next
Thank you.
we'll start with singly linked list. So I have already taught you this, and I don't know how much you remember. So we are going to start again from there. Just a minute. Okay. So is it visible to you?
Yes, ma'am.
Yes, ma'am.
Okay. So array we already know. So every data structure has some advantages and disadvantages. It is obvious. So then what should we do with the disadvantage? So we have to use the array, which we have to use the data structure which is most appropriate and which we need for our work. Every data structure may not be useful for us equally at a given circumstance. Okay, so which one we need, based on that we are going to use the data structure. So before starting with linked list, I want to discuss the disadvantage of array. Okay. So the number of elements to be stored in an array should be known in advance. Otherwise, what will happen? There will be overflow. Suppose there is an array, and an array you define the size of the array like A50. That means if it is integer type array, that means it can store integers only, and the name of the array is A, then 50 integers you can store. That means you have to know the need in advance, how much I need. If you need more than 50, there will be overflow. Okay, because you cannot take extra space during runtime. When the program is running, that time if you feel that it exceeds 50, extra space will not be given. So that is one disadvantage of array. Array is a static structure, which means the array is a fixed size. You see, it is static. You cannot change it during runtime based on your need. It is static, so you have to declare it beforehand. So what we do, we generally take more size, okay, than we need, so that even if it is extra, it is not less. Even if it's extra, then it's okay, but it should not be less. So in that case, what happens? We are wasting some space. which could be used for some other purpose at that time by the computer. But we are using it for the array, so we are reserving it for a purpose. So this cannot be used for some other purpose during runtime, even if you are using less number of elements. So array is static. That is the second point. Insertion and deletion are quite difficult in an array as the elements are stored in consecutive memory locations and the shifting operation is costly. Okay. Why the shifting operation is costly? Suppose this is an array. By here costly, I don't mean I'm that about money. Okay. Here costly means time wise it is costly. Okay. It is going to take a lot of time, and time is very, very important for computer. Remember it. So suppose this is an array and it has the values stored in it, suppose 5, 9, 10, 18 and so on. And suppose there are 1,000 of values stored in the array. Okay, so 1,000 values are stored in the array. And if I want to delete 9, then how many values you have to shift?
2, ma'am.
2. I said 1,000 values. I have not written 1,000 values.
Oh, okay.
Ma'am, 999.
Yes.
So all the values which are present in the right side of this, you have to shift. Isn't it useless? It's a useless operation.
Yes, ma'am.
You're doing
Yes,
basically.
ma'am.
Okay.
Yes.
Similarly, if you want to enter something, suppose there is already a value 7 here, and you want to enter a new value in this position. Okay, suppose you want to enter 16 in this position. Again, you have to shift all the values to the right. So this type of things makes it costly. Costly means unnecessary consumption of time. So this is a waste of time. Next, allocating more memory than the required leads to wastage of memory space, and less allocation of memory also leads to problem, which I already said. If you allocate too much of memory, you have allocated for 50 and you are only using 5. So you are wasting the space for 45 integers during the runtime, which could be used for some other purpose. And if you are allocating for 50 and in the runtime, if you need 65, then there will be overflow and it cannot be allocated. So either way, there is problem. So all these are the disadvantage of array. So this leads to the introduction of another kind of linked list to solve these problems, which is called, another kind of data structure, which is called linked list to solve this problem. So the first type of linked list, I said that linked lists are of various types. It can be singly linked list, it can be circular linked list, it can be doubly linked list, it can be priority list, and so on. So we will study each type. So first we will start with singly linked list. If you understand the algorithms of singly linked list, then you can easily understand, other linked list algorithms as well. So first you have to pay attention to singly linked list. So why it is called singly linked list? First of all, you see there is a single link between all the nodes. Each one is called a node. Okay, and there is a single link which is connecting all the nodes. Now one node has two parts, the data part and the address part. Okay, so this data part, it can store many things. It can store integer, it can store float, it can store character, it can store many things. Okay, and this one, the next part, will store the address of the next node. Okay, so that is how it is linked. Why it is linked? Because this node, this part is storing the address of this node. This node, next part is storing the address of this node. This node, next part is storing the address of this node. And this way it is connected like a, list. So a linked list is a linear collection of data elements called nodes. So each one is called a node. You have to remember these terms. These are the basic terms. Okay. The left part of the node contains data. Okay, so this part will contain the data. The right part of the node contains a pointer to the next node. Okay. Why pointer? Because a pointer only stores address. I told you that few concepts you have to brush up. I wrote in the group, okay, that computer science students need to brush up few concepts like we need here. We need structure, we need pointer, dynamic memory allocation, and all this. Okay. So please go through these chapters. So the right part of the node contains a pointer to the next node. What is a pointer? Anyone?
Ma'am, a variable that contains the address of data.
Okay, it is a variable which stores the address. That much is sufficient. Okay. So that means there is a pointer. That means that variable can store the address of the next node. I hope it is clear. So then who will store the address of the first node? A special pointer which is called a start, or in some book you will also see head, H-E-A-D, head. Okay, so start and head, both the terms are used for a special kind of pointer which will store the address of the first node. Okay, and at the end, to mark the end of the linked list, here we will store null. This cross represents null. Okay, so the null pointer in the last node is represented by cross. Linked list is also called a self-referential data structure, since in this every node points to the next node of same type. Why it is called self-referential data structure? What is this? This is called a reference. It is referring to another node of same type. Okay. Means if this node is storing integer, this node is also storing integer. Next part is storing address. Here also next part is storing address. So one node is pointing to or referring to the another node of same type. Hence, it is also called a self-referential data structure. All the points are clear to you?
Ma'am,
Yes,
there is a
ma'am.
question.
Yes, ma'am.
Yes,
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 ma'am.
yes.
Ma'am, ma'am, all are same type of data, ma'am. That means if it is one is integer, then all are integer. If
All are
one is character,
integers. Yes.
okay.
If you want to store mixed type of data here,
Hmm.
then mixed type of data will be stored here also. But only integer, if it is stored here, then here also only integer will be stored.
Oh. Ma'am, can we do do like this, that in the first case, in the number
If you are
one, there
using
I
structure, you can
yes,
store.
ma'am. Oh, okay, ma'am. Okay, ma'am. Understood.
Okay. Now see,
Oh, ma'am, I have a question, ma'am.
yes,
Like, so linked list is like different arrays linked together or just the same array?
I didn't get you. Can you repeat, please?
No, like, are these different arrays linked together, or is it a
These
same?
are not arrays. These are not arrays.
So these are different nodes linked together.
Yeah, these are different nodes linked together.
Okay.
Why we are saying that they need to be linked together? So the memory allocation will tell you that. So these are suppose the memory addresses 1 to 10. Okay, and this is the data part and this is the next part. So start is the special pointer which stores the address of the first node. Here it is 1. Okay, but that is not compulsory. It can be another value also, because it is linked list. It is dynamic. It is not like array. It is dynamic, and it can start with 5 also. No problem. In this case, it is starting with 1. 1 is taken as the first address. So because it is storing 1, so we will come to 1 first, and we will see what is present in the data. H is present. Okay, and then we have to see that what is the next node we have to look for. So for that we will see the next part. The next part is says go to address 4. So we will look for the next data in address number 4. So the next data is E. Okay. And where to look for the next data at address number 7. So coming to address number 7, we get L. Next 8. So we'll come to 8. Again, we get L. And then next is 10. We come to 10 and we get O. And finally, in the next part, we get -1, that is null. So what do we get if we join everything? We got HELLO, that is hello. But you see, it is not stored consecutively like array. In case of array, it is stored consecutively. Here, it is randomly stored. And because it is randomly stored, we don't know where the next value is stored. For that, we need the address of the next node. Is it clear to everyone?
Yes, ma'am.
Can you repeat, ma'am?
Repeat.
Yes, ma'am.
You did not understand. Tell me.
Ma'am, at the first time, what you said, ma'am? What you have said? H.
Yeah, this is the data part. Every node has two parts. This
Yes, ma'am.
entire thing is a node. It has two parts, the data part and the address part. Okay.
Oh,
It is a
yes, ma'am.
structure in itself. You see, it is storing a data that can be a character, an integer, a float.
Ma'am, video is paused.
Is it visible to you?
Yes, ma'am.
Yes, ma'am.
Okay. So you see, this is a part. It can contain integer, it can contain character, it can contain float. Okay. But this has to be a pointer. So these two are different types of data. And different types of data are stored together. That means what? It is a structure. Is it clear? So every node is a structure.
Yes, ma'am.
So here every node, this is our node. Okay. So one node, the first part is the data part and second part is address part. So 1 to 10, this represent the memory address. So starting address is present in the pointer called start or head. So starting address is 1. So if I look for what is stored in 1, I will get H. In the next part, I have 4. That means the next address that I have to look for is 4. That means the address of the next node. At 4, I get E. Next part is 7. That means the next node address is 7. So I come to 7 and I get L. From here, I go to 8. In 8, I get L again. Next is 10. So at 10, I get O. And in the next part, I get null. That means the linked list ends here. So what did I get? HELLO. Hello. Now is it clear?
Yes, ma'am.
And what are these? These gray parts. These gray parts are either empty or this memory is used for some other purpose. Okay, so there are two possibilities. These are either empty or these memories are used for some other purpose. So just so you see, the first algorithm that we are going to study today is the algorithm for counting number of nodes. So how many nodes are there in this linked list that we have to count? So this is called a pseudo code. I told while I was teaching you C programming that this is the way of writing pseudo code. step by step, step 1, step 2, step 3, step 4. Okay, never write in Roman because there can be sub part of a step. Okay, so you can write 1.1, 1.2 in that case. So don't write in Roman, write in decimal. Okay. So step 1, initialize set count equal to 0. That means count is a variable whose initial value is 0. Next, initialize set pointer equal to start. So in start, you set a pointer variable. Okay, one extra pointer called PTR.
Ma'am,
Yes.
is start a predefined function?
It is not a function, it is a pointer variable.
Ma'am, that means it is it predefined or we have to define it?
No. The initial address will be given by the computer itself based on the free space that is available. Because we
Okay.
do in dynamic memory allocation, what happens? You take the memory in the runtime.
Yes,
It's
ma'am.
like calloc, malloc that you have used. You don't know
Yes,
what
ma'am.
is the first address, right? So that
Yes,
is
ma'am.
given by default by the computer. So you don't have to bother about it.
Okay.
So based on the whatever free space is there in the computer, that the computer knows, we don't know. So the computer will allocate. We don't have to bother about it. So next you see, we have taken a pointer variable and we set it with start. That means the initial value of pointer is the address of the first node, because start is storing the address of the first node, so that we can count from the first node. Now you see, repeat steps 4 and 5 while pointer is not equal to null. So we have to repeat, keep on repeating the steps till we get null. That means till we reach the last node. Set count equal to count plus 1 and pointer equal to pointer next. Now you see what's happening. So this is my start. And what is start containing? Start is containing address of the first node, right? So pointer equal to start means pointer is also containing address of the first node as of now. So start is pointing to the first node. From here, it will go to the second node. From here, it will go to the third node. Suppose there are 3 nodes only. This is null. So this is the last node. So initially count is 0. Initially count is 0, right? And pointer equal to start means pointer is containing the address of the first node. So now what we will do, count is equal to count plus 1. That means plus 1. Because the pointer is storing address of the first node. So this plus 1 means you are counting this node. And pointer equal to pointer next. That means pointer is now containing the address which is stored here. That means address of this one. Is it clear?
Yes, ma'am.
Clear to everyone?
Yes, ma'am.
Again, count is equal to count plus 1. So now it is counting this node and pointer equal to pointer next. That means now it will come here. It will store the address that is stored here. That means address of this node. So again, count equal to count plus 1. And when it will go to the next part, it will see that it is null. So this condition breaks. Okay, because this loop will run till pointer not equal to null. But now the pointer will get null. So this will break. And what it will do finally, end of loop and then write count. Write count means print count. And what will be printed? 3. Is it clear to everyone?
Yes, ma'am.
Okay. Now the interesting question comes is why we are taking one extra pointer to count the nodes when start is also a pointer. So why we are not doing start equal to start next? Then also we can count. Yes, we can count. If we move start then also we can count. But if we move start, then we will lose the entire linked list. Because whenever we traverse the linked list, we have to traverse from start. But if we move start, then start will contain the address of this node. That means this node will be totally lost. Again, we will move start. That means these two nodes will be lost. Okay, and we will not be able to get this linked list back ever, because we don't know their initial address. So we will not move start at any cost. We will take a separate pointer and we will move that pointer beginning from start. Is it?
Ma'am,
Yes.
PTR is the copy of start now.
Yeah, whatever address is present in start, that is present in PTR.
Yes, ma'am.
But the reason of taking PTR is that we are not going to move start. If we move start, then we will lose the nodes one by one. So that
Yes,
you
ma'am.
have to keep in your mind. So next you see, you said na different types of values can be stored in the data part. So see in
Yes,
the
ma'am.
data part, different two values are stored: roll number and marks. Okay, using structure. So in the data part, roll number and marks is stored. In the next part, the address is stored. So suppose the biology marks of the students are stored. So the first address is 1. This can be different also. I'm telling you again and again. It need not be 1. In this case, it is 1. So if I go to the first address, I will get the roll number S01 and the marks is 78. And in the next part, it is 2. That means the next address I have to move is 2. In 2, I get S02, 84. Next is 3. Where I get S03, marks is 45. Next is 5, not 4. So we have to jump to 5. Here I get S04, marks is 98. Next is 7. At 7, I get S05, marks is 55, and so on. This way we keep on moving until we reach 15. Here we get null. That means it stops here. Okay. So in between, we did not come to 4, we did not come to 6, we did not come to 9, we did not come to 14. I said that these spaces, these are either free spaces or available spaces, or these spaces are used for some other purpose by the computer. Okay, that is not known to us. Now in this case, suppose these are available spaces. Okay, so what the operating system does, you know that what is operating system?
Yes, ma'am.
Yes, ma'am.
What is operating system? Anyone?
Which operate the system?
Operating system is actually a system software.
Ma'am, it's a system software which runs different programs and take care of allocating processors and memory to a different program.
It seems you have totally learned the definition. Okay, actually operating, if I tell in very simple naive language, then operating system means it is a connection between the user and the hardware. Okay, something has to establish the connection between user and the hardware, because the user cannot use the hardware directly. So the operating system works as the bridge that helps the user communicate with the hardware or use the hardware. Okay, so it is a system software that helps the user use the underlying hardware. So there are different kinds of operating system. The most common one that we use is Windows. Okay, so what the operating system does, from time to time, the operating system keeps collecting the free spaces. What are the free spaces? And maintain a linked list for that. Okay, so that the free spaces can be allocated whenever required. So suppose 4, 6, 9, 14 are free spaces. So they will also come under a single linked list of free spaces. Okay, and the starting address of this linked list is 4. Here we have not written start, here it is written avail, because it is showing the address of available space. So the first available space is at 4. So the starting address is 4. What is the next available space? It is at 6. So you can come here and check out what is the next available space. It is at 9. And what the next one is 14. So at 14, you see it's -1. That means there is no more available space. So if I have to create a new node, then which one will be given to me? The first one, first address. So if I want to create a new node, then this first address, this node, this space will be given to me, that you can use it, and avail will become avail next. That means the next available space will become what? Here it will become 6. Is it clear to you?
Yes, ma'am.
Yes, ma'am.
Okay. So this is all about avail, because we will see this term in the algorithm and then you will be confused. So it is important that you understand now what is avail. So whenever one new node will be given, avail will become avail next. That means this will contain the address of the next available space. In this case, it is 6. Now, there are several algorithms. So first is inserting new node in a linked list. And this can be classified into 4 cases or 3 cases also. Okay. In some books, you will see 4 cases. In some books, you will see 3 cases. Both are correct. Don't have to be confused. Okay. So if I categorize into 4 cases, then we will see that the case 1 is the new node is inserted at the beginning. That means this new node will become the first node. In case 2 is the new node is inserted at the end. That means the new node will become the last node. Case 3 is new node is inserted after a given node. Okay. Suppose you say that I want to insert the new node after the node which contains 3, which contains the value 3. So the new node will be inserted after 3. Okay. And case 4 is the new node is inserted before a given node. That means suppose you are saying that I want to insert a new node before the node which contains the value 5. That means the new node will be inserted before the node which has the value 5. And these 2 cases can be merged and into a single case, like inserting a node in between a linked list. Okay, that is inserting at beginning, inserting at end, and inserting in between. This type also you can see in some of the books, and all these are correct. There is no problem with it. So we will see the cases of insertion one by one. So you see inserting new node at the beginning. So for that, you already need a linked list. So this linked list is already present, pre-existing linked list. Okay, and this is your new node. So allocate memory for the new node and initialize its data part to 9. You can take any other value also. Here in this case, they have considered that the data part will be 9. And where did they get this new node from? From the available space. Just remember that. So add the new node as the first node of the list by making the next part of the new node contain the address of start. So now you see we have a new node. So we have a new node that we want to join, and the first part, data part of this new node contains 9. Okay. So there will be 2 joining. One joining will be with this node. Another joining will be with start. So which joining should be first? Which joining will be first, that you have to think about.
Ma'am, can you repeat the question?
I said that, you see this is already an existing linked list.
Yes, ma'am.
Okay, pre-existing linked list, and this is the new node.
Yes, ma'am.
Okay. Now this new node will be the first node. You have to make it the first node. So there will be two joining. You have to join this.
Ma'am, first node should be new node should be added first.
So this node will be joined with this one because it has to come here, and this node has to join with start also. So which one will be done first? So can you tell that? So now you see, if I join this one, this new node with start, then what will happen? Start will contain the address of new node. Okay, and all this will be lost because we could track this from start only. But now if start contains the address of new node, if start contains the address of new node, then this entire linked list will be lost. Okay, so we will not change this one first. What we will do is, this is the new node.
I'm joining to the first one.
So you have to join this one with this one. Okay. So where is the address of this one stored? Where is the address of this one stored?
And start.
In start. So new node next part, that means this part will contain the address, whatever is present in the start. Okay. And then start equal to new node. So first this joining you will do so that it is attached with this one. Then you will not lose it. And then you join this one. Clear?
Yes, ma'am.
Ma'am, not properly. Can you repeat again?
Not properly clear. Okay. You see, this is the new node. You have to make it the first node. To make it the first node, you have to join this one with this one. Okay, it should go this way, isn't it? Because this is the
Yes.
first node. That means you have to join this one and you have to join it with start also. So with joining you will do first. So if I join it with start first, then start will contain the address of this node and all this will be lost because you have not stored anywhere. You have not stored the address, this address anywhere except start.
Yes, ma'am. Yes, ma'am.
Okay, so you will join this one first. That is, the next part of new node will contain the address of the first node. And where is the address of the first node? In start. Clear?
Yes, ma'am.
Then you will change the value of start. That is, now start will contain the address of new node. I hope it is clear to everyone.
Yes, ma'am.
Yes, ma'am.
So now you see the pseudo code. So if avail equal to null, means if there is no available space. Avail equal to null means the avail pointer, which we have seen here, this contains null instead of a value. That means there is no available space. In that case, write overflow and go to step 7, means exit. That means insertion is not possible. Because there is no available space, then how you will create new node? Okay, that is the first step. Next is, if there is available space, then set new node equal to avail and avail equal to avail next. That means what? So new node equal to avail. That means new node will take which address? 4. That is avail. And avail will become avail next. That means avail will become 6. Is it clear?
Yes, ma'am. Clear.
Okay. So this, up to this much, will remain the same for every insertion algorithm. Okay. Up to this much, up to step number 3. And this will also remain same. New node data part, you insert the value. So in the data part, you insert the value. This also remains same. Next, new node next equal to start. That means the next part of new node will contain the address of the first node, which is present in start. That is new node. next equal to start, and set start equal to new node. That means start will contain the address of new node. So 2 joinings are done and exit. Clear?
Yes.
Yes, ma'am.
Okay. So one more algorithm we will see and we'll finish today. That is inserting new node at the end. So now this new node you have to insert at the end. Okay, means where? After this one. So there is a pre-existing linked list. Okay, and you have taken a new node. So in the data part, there will be whatever value you want to insert. In this case, it is 9. And because it is going to be the last node, so the next part will contain null. Is it clear?
Yes, ma'am.
So the next
Yes,
part,
ma'am.
of this will contain null because it is going to be the last node now. So take,
And ma'am, the null will take the address of 9. No, ma'am?
null will take the address.
The
No.
previous null. The previous
Oh,
null.
yeah. So this will contain the address of new node, not 9. So take a pointer variable ptr. Okay, so for that we have to traverse from here to here. So before we join, we have to come to the last node. For that we have taken one extra pointer variable called ptr, whose initial value is start. So it will start from here and it will keep moving. Okay, it will come here up to here. How it will come here? When it will get the next part null, then it will stop. Okay, here the next part is still null, no changes are made. So the pointer will come from here and it will come up to the last node and then it will stop. So this is pointer now. Call it pointer, ptr. So now what will happen, you see? What will happen? Pointer next part. That means this part will store the address of new node and the joining is done. Is it clear?
Yes, ma'am.
Ma'am, that mean we could change the address of null.
Yeah, we have to change the address of null. Now it cannot contain null. Now this is not the last node. This is the last node.
Yes, ma'am. That's why I'm asking. Okay, ma'am.
So you see the pseudo code here. So these steps will remain the same. If avel equal to null, write overflow and go to step 10. Okay, so step 10 means wherever you write exit, that step you write down. In this case, it is step 10. End of if, set new node equal to avel equal to avel next, new node data part equal to value. So all these steps will remain same for all. Okay, and new node next part is null because it is going to be the last node. Then set pointer equal to start and repeat step 8 while pointer next not equal to null. That means till pointer reaches the last node. So what you will keep repeating? Pointer equal to pointer next. So pointer will keep moving till it reaches the last node. Okay, end of loop, and set pointer next equal to new node. That means pointer next part will contain the address of new node and exit. Is it clear to you?
Yes, ma'am.
Okay. So it's already 12:49. So tomorrow again we have a class and we will discuss from that time. Okay, we'll continue from here. So I hope whatever was taught today is clear to you.
Yes.
Yes, ma'am.
Yes, ma'am. Excuse, ma'am.
So yes,
Ma'am, which book I should prefer for this?
I have shared a PDF with you. Okay. Actually, the most standard book for data structure algorithm is Foreman. Okay. But it is also a bit difficult for the beginner.